Okay, today's topic is infinite and partial series. Now, yesterday you read and studied something like this. That's the sequence of positive integers. Now, what this is, it's related things, that's the infinite series, the sum of the positive integers. Now, the sum of the positive integers is a divergent series, it's called. There's no number that it adds to because the integers just keep increasing. But there is such a thing called a partial series, and one of the most famous is the sum of the first n integers. And this is a famous problem, and legend has it that young Carl Friedrich Gauss was asked this question by his teacher when he was in grade school, and he immediately knew that the answer was 50-50. Because if you match the first and last terms, they all add up to 101, and there are 50 such pairs, so the sum is 50-50. Now, if you look in a book, they give formulas for this, and they're found on page 775 as to how to do this. But the formula for the sum of the first n terms in an arithmetic series is S sub n is equal to n over 2. Because there are 50 of these pairs in here, so n over 2, you divide the number of terms by 2, and then t1 plus t sub n. Now, some might ask, and you usually do in class, well, what happens if there's an odd number of terms? And it's a good question. And if you think about it, if there were an odd number of terms, there wouldn't be a perfect number of pairs. There would be a number right in the middle, and it would have to be the mean of that data of those terms, the absolute arithmetic mean. So, if you think about adding this amount, which is 101, that mean would be exactly half of that amount. So that would be added in an extra half a time, essentially. And you can give this some thought, but it makes a lot of sense if you think about it, and you write out a couple examples and see how it all works. But the formula does hold even if n is an odd number, and n over 2 isn't going to be an integer value, but still the way things work out is that this will end up producing the partial series for the sum of the first n terms. Now, this isn't as useful a formula as, if you recall from yesterday's work when you read and studied, the nth term of an arithmetic series, or sequence, is first term times, plus, I should say, the number of terms minus 1 times common difference. Now, if you substitute that into here, you get n over 2 t1 plus t1 plus n minus 1 times d. So this can be simplified a little bit to 2t1 plus n minus 1 times d. This is a much more useful formula than the one that's found on page 775. You probably want to use this one in almost all the cases. All right, well, let's see how this works. Let's say we got problem number 16, which is, okay, here's a partial series. 97 plus 131 plus 165. It says find S37. Well, first thing you do is find the common difference, which is 34. The difference between it, and if it remains consistent, then it's an arithmetic series, obviously. So the sum of the first n terms is pretty straightforward. You get 34 over 37 over 2 times 2 times 97 plus 37 minus 1 times 34. And I would suggest just doing this all at the same time on the calculator, and then the answer here is 26,233. All right, that's pretty easy. I don't even know why I'm doing an example for you. You can handle that. Now, another question that's asked, and it is a little bit more difficult. That's why I'm doing video and examples today as opposed to yesterday. I don't think it was necessary. Let's say that you have a partial series. I should put this 27 a little bit. S sub n is equal to 97 plus 91 plus 85. And if it says find n if s sub n is equal to 217. Now that's an interesting series because the common difference is negative. Now ultimately, you can see that these terms, sooner or later, the sum is going to turn negative because these are, this is going to continue to decrease and get into negative territory. So this is still a positive number, but it's going to take a while for that sum to become negative because the negative numbers are going to have to build up and become greater and greater. All right, well, you just substitute the values into the equation. N over 2 times the formula, 2t1 plus n minus 1 times d. Okay, putting the numbers in, we got 217 is equal to n over 2, n being unknown, 2 times 97 plus n minus 1 times negative 6. Now what I would do is first thing is I would get rid of that 2 and multiply through it to both sides, and you get 434. All right, now the n is still outside here, and inside 2 times 97 is 194 minus 6n plus 6. What's going to happen is when we distribute this through, we're going to end up with a quadratic. Now 194 and 6 add up to 200. 200 times n is 200n. N times negative 6n is negative 6n squared. So making this into a quadratic, you'd want to put the, I always keep the quadratics positive. So 6n squared minus 200n plus 434 is equal to 0. Now, just run your quadratic formula program. I'm going to put this up here so just to show something. Okay, so, I got the wrong calculator. I apologize for that. Okay, in any event, the n comes out to be 31, and then there's another number. I can't remember what it was for this problem. But if it's a negative number or if it's a non-integer, it's not the answer because the n has to be an integer. You can't, remember these are term numbers, so n must be an integer value. And when you run a quadratic formula, a positive integer, I should even go so far as to say, because term numbers have to be positive. You can't have a negative term number. So if there's a negative number that pops out of there or a non-integer value, then that's not the answer. And if you get two values that are non-integer, well, then something else is wrong in there. Okay. So you have some of that. All right, we also have geometric series. And if you're interested in the derivation of these things, and we always did it in class. I used to make somebody come up to the board, but unfortunately that's not going to be the case here. To derive these things. They're in the book, the derivations of these formulas that are found on page 775, but they're done sort of with numbers. So if you want to, you can do it, although I would hesitate, or I would venture to guess that not too many people are doing that type of thing right now. I offered the bonus question on the project, and I didn't see anybody turn it in. I don't know if anybody did it, but I should have told you that that solid figure, both the volume and the surface area were integer values. So if you're interested in it, it's a very interesting problem. If you want to know the answers, ask me. All right, so let's look at number 18. 36 plus 54 plus 81. Couldn't read my own writing. Okay, it says find S29. All right, well, this is geometric because there's not a constant difference. So you find the common ratio by dividing first term by second, or second by third, whatever. You know, these are all powers. They're multiples of 3, so you get 3 over 2. All right, so to find S of 29, the formula is, well, let me write the formula down. You haven't seen it. It's kind of a bizarre formula. So S of n is equal to T1 times 1 minus r raised to the n divided by 1 minus r. And which is a little bit strange. And I would encourage you to look at the example where it's in the chapter where this formula is derived. I don't have the page number written down here. Oh yeah, I do. It's on page 770, derivation of this formula. Again, we did it in class, and it's an interesting derivation, and it was always good with a student up there. I'm sure you guys miss that. Okay, so substituting in here, we have 36 times 1 minus 3 halves to the 29 divided by 1 minus 3 halves. Now, there are various ways that I think that do the calculator here. This obviously is an easy number to deal with, and you can have this could be. You might even do this whole thing first and then multiply it by 36, and that turns out to be 9,203,578. I believe that's the number I have written down here. Not important, that really. Point something or another. 8 something. All right, just for practice, you should do one. A more difficult problem, obviously, is like we did for the arithmetic, is if you're given the series and say, here's the sum, 425, 971. What's the term number? Again, substituting in. Well, here, remember the common ratio is 2. That's pretty easy to see. 425, 971 is equal to 13 times 1 minus 2 to the n over 1 minus 2. Okay, so let's look at this equation. Now, this is 13 over 1 multiplied by this stuff. So this is a number on the bottom of the fraction. It's a negative 1. So that 13 divided by negative 1 is negative 13. Okay, so I could, and you can, make a number out of this, and then divide this side by that number. Okay, and that's equal to 1 minus 2 to the n. Well, you want to have the term that has the variable in it as a positive number. You can't have that negative sign on front of it. So we can put that over here and move this stuff over to the other side, where it becomes positive. Okay, now the answer here is that since this is an exponential, is n is log base 2 of 425, 971 over 13 plus 1. I would encourage you to isolate like so, with the given information sort of in it, so to make sure that you're doing things correctly. And if you do this, n turns out to be 15. Okay. Now, a special type of geometric series, and this is encountered in many fields, actually, is what's called a convergent series. And number 30 is such a series. And it looks like this. The sum of the first n terms of 25 plus 20 plus 16. Okay. So these numbers are decreasing every time, and this is a geometric series, and we decrease by 5, by 4, and so forth. So the common ratio is 20 over 25, or 16 over 20, which gives us 4/5. Okay. Now, ultimately, the millionth term isn't going to be very big, so it's not adding very much more into it. And you got to think of this. Remember, the formula is T1 times 1 minus r to the n over 1 minus r. And you'll just, we talked about limits earlier this year, and we wrote them like this because we informally define limits in any time. As n approaches infinity, and what we have here for this r, if that r, absolute value, because it could be negative. Remember, these terms could alternate positive and negative, so r could be negative. But if that r is less than 1, between 0 and 1, it's got to be greater than 0, obviously, otherwise it doesn't even exist. But as n approaches, and this is if, then r to the n approaches 0. Because, you think about it, raising, 1/2 to the 1,000th power, there's really not much left after you do that. So the top of this fraction becomes 1. And this is for a convergent series, and it's only under these conditions. So this series converges to this number. You take 25 and multiply it by 1 over 1 minus 4/5. Or 25 times 1 over 1/5. Now, what you do is multiply by the reciprocal, so that's 125. This is an easy example, but others are similarly found. If it converges, and only if it converges, does this apply. This doesn't apply to those that don't converge. This is a special situation. All right. Well, here's your assignment. I'll squeeze it in right here for the day. Now, somebody asked me, is there going to be a quiz on this? I don't know. I mean, I don't know if we'll cover enough. I don't know if we'll cover enough to have a quiz on this. We're not supposed to give out any quizzes or any kind of assigned work after such and such a day. I can't remember exactly what that day is. But at the same time, I mean, if you can't give out any assigned work, well, then what are you going to do? So I will continue to do things like this. We probably won't have a quiz, but I could collect something, like one of these assignments. Just say, all right, turn in this one. So just to keep you honest, not that you guys haven't been honest. I think everybody's been pretty good. Okay, well, there you have it. If you have any questions, get a hold of me. This shouldn't be too hard. Tomorrow we'll cover binomial theorem, which is kind of interesting. And I'd like to cover some series that are common in higher level mathematics. We always did in class, and we also did something else called mathematical induction, but I don't think we're going to get there this year because things took a little bit longer, and especially after I slowed down after the initial beginning when I was moving too quickly, so I heard. All right, well, I'll talk to you tomorrow.